Hi, Chris Kuzmal here. We're talking about relational logic. We've covered pretty much all of how to express a relational logical sentence and pretty much all of the semantics, I believe. And so now it's time to be able to introduce ways that we can manipulate relational logical sentences. In other words, what amounts to rules of inference. And we're actually jumping a little bit ahead because we're satisfying a requirement for an assignment that I provide in middle of chapter 6. And it asks us to demonstrate common quantifier reversal, existential distribution, and negation distribution. So we're going to do that here, and you should rest assured we're going to talk about it again when we get up to chapter 8, but it's always good, I think, to see an example. So so here we have our first example, which is for common quantifier reversal for the universal quantifier. And I have to take a note. In order to be able to show you this in a kind of complete way within the context of the example, I have to shrink my world. I have to take it down to only two object constants, a cat and a ball. They're shorter words than Dasha and ball one, for example, or a leopard. And there's fewer objects, so I can fit the grounding of the sentences that I want to use onto the page. In fact, I can fit both the pre and post quantifier reversals. And so here on the left, I have the statement for all x and for all y, blue of x implies cute of y. And what we can do, what common quantifier reversal says, is that if they're the same quantifier, whether it's a for all or there exists, then we can swap them. And so that's exactly what I do here. And so one of the questions you might ask is, well, okay, I see the rule. I can swap for all things without penalty, but it's valuable to recognize that where the truth comes from, as it were. And so the things that I just covered up with the green box, that's, let me just uncover it, that's a portion of the overall logical sentence. And you'll notice that everything's anded together. Part of the intuition is that whether you're on the left side or the right side, the black side or the purple side, every part of the logical sentence, that's every implication in the logical sentence is glued together using ands. And so the parenthesization doesn't really matter, okay? And that's sort of at one level what common quantifier reversal means. But it's also the case that we can recognize that the first clause here that I cover up with the green box contains blue of cat as the antecedent for the implication, which is to say each of those implications, because the cat's not blue, each of those implications, or at least let's assume the cat's not blue, then each of those implications evaluates to true. Both of them evaluate to true, okay? Or alternatively, both of them could evaluate to false. Perhaps it's a little bit easier to recognize the significance there. If both of them evaluate to false, then that falsity, when we rearrange by swapping x and y, that falsity spreads out across both of the larger conjunctions that make up the sentence after we've swapped the order of the universal quantifier. So that's another slightly more analytic description of why common quantifier reversal is allowed. Now, you can also do common quantifier reversal in the case of an existential operator, and it's for much the same reason. And once again, all of the operators are disjunctions, and so it doesn't really matter what the parenthesization is, and that means you're reordering a big disjunction just as before you were reordering a big conjunction. It doesn't really matter, and that's why you can swap the for all x and the for all y, or that there exists x and there exists y. The more interesting case is the case of existential distribution. Here, the black logical sentence can be converted into the purple, but you cannot always convert the purple logical sentence into the black one, and that's because we have the disjunction of these two conjunctions. That is allowed to be a conjunction of disjunctions, but you can't go the other way. You can't distribute this and out and replace it with or in this direction and maintain maintain it to be the case that you have entailment from one to the other. So the black sentence entails the purple, but the purple does not entail the black.